Hi everyone, today we are going to deal with the introduction to sets. In this chapter, we'll go through four topics. First is set and their representations, types of set, operation on sets, and Venn diagram. In this session, let us learn what are sets and their representations and types of sets. Before starting its representation, let us know what are sets. In everyday life, we often speak collection of objects of particular kind, such as crowd of people, a pack of cards, and a number of students in the classroom. We can count the number of students in the particular classroom. Or a cricket team. It consists of 11 number of players and various kinds of triangles. We can name the kinds of triangles. It is a definite in number. It means collection of objects of a particular kind. Sets means collection of objects of a particular kind. Can say the example also, set of odd natural number less than 10, that is 1 3 5 7 9. If I come across the non-set, if it is not a set, if I going to give the example, I will say the five most renowned mathematician of the world. Five most renowned mathematician of the world. So it is not possible to count the most renowned mathematician of the world, or we can say the five of the world. We can tell the five cricketers of the world. We cannot count the five best cricketers of the world. So it is the example of the non-set. Sets are usually defined by capital letters and its elements are represented by the small letters. And if I am going to give the example set used in the mathematics, that is n, it is a set of natural number. Z, it is a set of integer. Q, set of rational number. R is a set of real number. Z plus, it is a set of positive integer. Q plus, it is a set of rational numbers. And last is R plus, it is a set of positive real number. It is a set of positive real number. And let us move on to the representation of set. If A is an element of a set A, if A is an element of set A, we say that A belongs to A. A belongs to A. This symbol denotes the belongs. A belongs to A. If A is an element of a set A, we say that A belongs to A. It represents the set. It represents set. Next, the representation of the set in the two form. One is roster or a tabular form. The next is the set builder form. Let us move on to the roster form. If all the elements of a set are listed, the elements are being separated by commas and are enclosed within the braces. It is clearly shown. It is enclosed within the braces and separated by commas. Example is, it is set of all even integer less than 7. All even integer less than 7 means we are going to write 2, 4, 6. it is in the roster form. Or if I say set of all vowels in the English alphabet, we will write as A, E, I, O, U. This is in the set builder form. Next, let's move on to the set builder form. It possesses a single common property. In set builder form, all the elements of a set possess a single property which is not possessed by any element outside the set. Example is clearly shown here. We will write this in the form, in this form. It is a vowel in the English alphabet. Here the question will be the set of A, E, I, O, U, and your answer should be in the set builder form. A is equals such that X is a vowel in the English alphabet, where in the roster form you have to write in the numbers or letters. Got it? It is in the set builder form. Let's move on to the types of set. Sets, which first one is the empty set. Set which does not contain any element is called an empty set, and it is denoted by simply a braces, or we will write as a null set or a empty set. We call it as a null set or empty set or a void set. And it is example, if I give the example, a set of apple in the basket of grape is an example of empty set. A set of apples in the basket of grape is an example of empty set, because in grapes basket there are no apple present, right? So we'll tell it is an empty set. Here the example, one more example is given. 1 is less than x is less than 2. X is a natural number. What is the number? This is lie between 1 and 2, or 1 is less than x is less than 2. That is 1.1, 1.2, 1.3, 1.4. So 1.2, 1.3, 1.4 and all is a decimal number, so it cannot be a natural number. So we can write it is an empty set or a simple braces we can write. Now let's move on to the finite set. Finite set is a set which is empty or consists of a definite number of elements called finite. Otherwise is called infinite set. Otherwise it's called infinite set. For example, it is a set of days of a week. It is a countable number of days. We can count the days of a week. There is a 7 days in a week. So it is a finite set. And if we move on to the infinite, it is a point on a line. We cannot count the points on a line. It is a infinite number of points on a line. It is an infinite number of points on a line. It is uncountable. So we'll say it is a infinite set. Next is the equal set. When it is equal set, if the two sets are given, if A and B are said to be equal, if they have exactly the same element. If the set of A element in the set A is same in the set B, we call it as an equal set. Set does not change if one or more element of the sets are repeated. For example, if I write A equals 1, 2, 3 and B equals 2, 2, 1, 3, 3, this is also equal because it does not change if one or more element of the sets are equal. But the number present in set A is also present in the set B, that is fine. We call it as equal set. Now it is subset. When we call it is a subset. A subset is a set. If a set A is said to be subset of set B, if every element of A is also element of B. See, in set A, the same number exactly is present in the set B. We call it as the subset, or simply we can write A subset B. This is a symbol to denote the subset. This is the symbol to denote subset. Next, now move on to the intervals as subset or F. The set of real numbers A is less than Y less than B is called an open interval. Open interval means it will be denoted in a small bracket, whereas the closed interval is denoted by, we call it as a big bracket or a square bracket. In small bracket we call it as open interval, and a big bracket we call it as a closed interval. If I write big bracket A comma B, if it is closed, we'll say it is an open interval from A to B, including A but excluding B, including A and excluding B. And if I write A comma B, it is an open interval from A to B, including B but excluding A, including B and excluding B. In excluding B, it is an interval as subset of R. Next, now move on to the power set. It is a collection of all subset of a set A is called the power set of A, and it is denoted by P of A. If I take the example, A is equals 1, 2. How you will write the power set? We will write this power set as, it is also include the power set also includes the null set. It is denoted by, null set is denoted by this symbol, and we'll write as 1, 2 and 1, 2. 1, 2. P of A can be written as null set, set 1, set 2 and 1, 2. If set A, if A is equals 1, 2, the power set will be null set, set 1, set 2, set 1 and 2. And if we move on to the last set, universal set. If we move on to the universal set, if I give the example, A is equals 1, 2, 3, B is equals 2, 4, 6, C equals 1, 3, 5, 7. Then universal set can be written as 1, 2, 3, 4, 5, 6, 7. Why? The repeated term should not be written in the universal set, but it should contain, but the universal should contain the element should be same as in set A, B and C. It should be picked from all the set, but the repeated number should not be included in the universal set. This is the type of set we'll come across this chapter. In the next session, we'll see the operation on set and Venn diagram. Thank you.